Welcome to a new part of the ISM Statistics 1 exercise set, this time with an exercise on measures of central tendency. Let's take a closer look at the exercise. The following sample resulted from asking a group of students about their income in euros from side jobs. What should we do with this? First off, prepare a frequency table. Second, calculate the mode, calculate the median, and finally calculate the arithmetic mean. Well, let's work our way part after part through this. However, before we can start, we need to do one additional calculation, or more or less arrangement. We need to start with our original data set and rearrange this in ascending fashion, because this makes the rest of the work a lot easier. So we start by taking the smallest numbers. We have the 0 3 times. So we copy the zeros, we copy the next smallest number, the 20, the 100, then the 200, then we have once the 400, and finally twice the 450. So having this ordered data set will, in the next few exercises, help us quite a lot. In particular, we use this ordered data set to start with our first exercise with calculating the frequency table. Frequency table has, in our case, 4 columns for the values, the absolute, relative, and accumulated relative frequencies. For the values, we need to consider that each value is entered only once into the frequency table. So even though we have the 0 3 times, it's entered only once. However, as the 3 is present 3 times, it has an absolute frequency of 3. Well, and except for the 250, which appears twice, all the others have an absolute frequency of 1. Okay, how to get from the absolute to the relative frequencies? For this, we calculate, or we consider, the amount of observations. We could either sum up all the absolute frequencies or count how many data points we have. In the end, we will get a number 9. So we divide all the absolute frequencies by 9 and getting this result. So far, so good. Then we have the accumulated relative frequencies. How do we get those? Well, we always consider the value, or the accumulated relative frequencies, of the row before the current position, and add to this one the relative frequency of the current row. So starting with the first value, first entry, before this, in a row above this, there's no entry, so we start with 0 plus the relative frequencies for the first row. So for the 0 is 0.333. That's the first entry here. Then for the next entry, for the row with the 20, with value 20, we add to the 0.333 the relative frequency of 20, which is 0.111. So we get 0.4444. And we carry on with this till the last entry, and in the last cell we always need to arrive at 1 or at 100%. Meaning, if we get something different than 100%, somewhere in between there needs to have happened some kind of calculation error. So this then is our frequency table. This is basically everything we need to do in part A. However, we need this frequency table to solve the next exercise. In the next exercise, part B, we are asked to calculate the mode. What's the mode? The mode is the most frequent value. We can see here, most frequent, the one with the highest absolute frequency, is the value 0. So we easily can use this frequency table to see that our mode here is the value 0. This already concludes part B. For part C, for calculating the median, we however have to do a little bit more. First off, we again consider this ordered data set, and for the median we need to take care that we select the right formula, because for the median we have 2 different formulas, And well, the selection of the right formula depends on whether we have an even or an odd number of observations. Here, as we mentioned before, we have a number of observations of 9, so an odd number, meaning we need to use the second formula. This, however, is relatively easy to get. We just need to calculate this index, which is 0.5 times n plus 1. N in this case was 9, so we have 10 times 0.5, or divide by 2, giving us 5. So we need to consider entry number 5 in the ordered data set. And we can see the fifth entry is a 100, so our median here is 100. It was still relatively easy. So we switch to the fourth part, calculation of the arithmetic mean. In the first approach we use the ordered data set, because the simple definition of the arithmetic mean is add up all the different observations, divide them by the number of observations. So we add everything up and divide this by 9, giving us a result of 180. However, we could also do this slightly different. In this case, we do not start with the ordered data set, but with the frequency table. And we do not add up all the numbers, but before summation, we multiply the values with their absolute frequency. So we go through the different rows of the frequency table. And well, here we only save writing down the 0 3 times and 450 2 times. But you might imagine, if you have a lot of observations with absolute frequencies larger than 1, you could actually cut down on calculation time. So this might make your life easier if you have a larger data set with only a limited variance according to the values. So here in the end we get again as a result 180, so the same result as with the first alternative. However, we can also do this slightly differently as well. Again, for this we consider the frequency table, and instead of multiplying values and absolute frequencies and afterwards dividing this by the amount of observations, we directly here multiply the values with the relative frequencies. In the end, if you consider the definition of the relative frequencies, it's exactly the same as alternative 1, but for some people this might look more interesting or easier to be calculated. So here, each value multiplied with the relative frequency, everything added up, as done here, results in exactly the same result as the two approaches before. So this done not only concludes part 4 of this exercise, but the whole exercise. I hope you all enjoyed listening and learned something from this exercise. Until next time, see you and goodbye.